Okay, welcome back to video 2 of this discussion on throughput accounting. So we said in video 1 that what we try and do is we rank which product to make based on the contribution per hour in the short term. All this is very much in the short term because we have scarce resources which we will rectify. An organization should always be aiming to rectify or expand on their machines or fix the machine, whatever. Okay, let's carry on. Exactly. So the question here now is, let's make as many of y, and then let's see. So let's do the math. Let's actually make the product and see what happens. So we see that again, please refer to the PowerPoint so you can sort of see what's going on. So it says that there is demand for 10,000 units of y, and this requires 1 hour each. So that means that you're going to use 10,000 hours. That means you have 38,000 hours left. And I'm just going to do the I'm sure you know exactly. You can do the math to it. Let me just make it a bit more practical. Let's see what's going on. So if y needs, if you're making, 10,000 hours for 10,000 units, that means that there are 38,000 hours left. And for x, you need 2 hours per unit. So that means you can only make 19,000 of x. So we know that the optimal production is therefore 19,000 of x and 10,000 of y. We're actually going to test this and see what would happen if we had said, oh, well, I don't really know. What if I'm just going to have a go and make 20,000 of x and whatever the balance is of y? We'll see that we actually get that the contribution is actually less. But this is sort of how you'd work this out. And then, of course, from here, we just carry on and whatever, 19,000 times the contribution. And so we'll see that in the following slides. But that's kind of the process of reaching your answer. So let's go on to the next slide and see what we have. So again, I've already put everything here. What we have is, with 38,000, we can make 38,000 hours left. We can make 19,000 units of x. Again, I give you the optimal deduction. And again, let's say, I've said here, let's test it. Say, for example, you said to me, Oyen, I don't trust you. We're going to make 20,000 units of x anyway. So we need 40,000 hours, right? Because 2 hours per unit makes 40,000. And if you go back and look at your slides, the contribution for making 20,000 units of x is 20,000 times 5, which is 100,000. That means you would have 8,000 hours left, right? Because you would have 48,000 hours in total. And because you'd have 48, and you've already used 40,000, you have 8,000. And if you need 1 hour to make y, you can only make 8,000 units. So if you make 8,000 units of y, that's 8,000 times 4, that's 32,000, and your total contribution is therefore 132,000, right? 100 plus 32. So say, for example, we'd gone with the optimal plan that we earlier discussed, based on the ranking, based on contribution per hour. We would have made 10,000 units of y, we need 10,000 hours, gained an initial contribution of 10,000 times 4, which is 40,000. Then we would have made 38,000. Then would have had 38,000 hours left to make 19,000 units of y, giving us, therefore, a contribution of 19,000 times 5, 95,000. Add the two together and you get 135. So you can see that with the optimal plan, we're actually £3,000 more better off in contribution by using that optimal plan and not just ignoring it. So it's really key to have a go and practice this just for yourself to see that it does work. Just to compare when you actually rank things. I mean, in a crazy sort of way, you could just but the problem is if you have a range of products, because you could have 4 or 5 products and you have to rank them based on their contribution per hour. I guess with 2 you could just test both and see what gives you the optimal contribution. But it's better to do the process that we're working on. Right, what I'll do there is I'll stop that video because that's technically the end of what we refer to as what's referred to as a key factor analysis. So that's pretty much arguing and saying, what do we do when we have minimal resources? We have to look at how we can get the highest contribution per hour for what we have. And this applies naturally in life. When you don't have very much time, typically you try and make the best of that time, quickly. Maybe it's at the end of the day at work, you try and do something quickly, and then because the next day you're going to have more time to do other things that probably actually give you a higher profit anyway than that. Okay, great. So what I'll do is I'll pause that there. That's the end of the second video. This will be the end of the second video on the traditional way of dealing with limitations and when resources are scarce. And then we'll talk about throughput accounting in the third video. See you then.